Hello everyone, thanks for stopping in, and today we're going to be looking at our last note packet for Math 100. And in this packet we're going to be factoring some more trinomials, but these trinomials will have a one value in front of the x squared. Remember, all the trinomials we've seen so far had 1 as the coefficient for the x squared, but now we'll have a different number. And we're going to do something a little different with these. The first thing we're going to do is you're going to take the squared coefficient and the constant coefficient. So the first and the last one, and multiply them together. So 3 times 8 is equal to 24. Now, just like before, we're going to make a table that will help us find the answer. And now, our goal is to find two values that multiply to 24, but add to 14. So just like before, we're trying to add to the middle value, but instead of multiplying to the last value, we want to multiply to the product of the first and the last. So we want to multiply to 24. Instead of multiply to 8, right? That's the difference here when you have a different number than 1 out front. So, how can we multiply to 24? Well, everything's positive, so I'm only going to care about the positive factors of 24, right? I don't need to worry about negative numbers in this example. Now, you could have 1 and 24, 2 and 12, 3 and 8, or 4 and 6. Those are my possible ways to multiply to the number 24. Now, I want to check each of these sums. The first sum, 1 and 24, gives me 25. 2 and 12 gives me 14, which is actually what I was looking for, right? But let's finish the table. 3 and 8 gives 11, and 4 and 6 gives 10. So the row I'm looking for is this one. Now, what we're going to do with this is we're going to split our trinomial from 3 terms into 4 terms. I'm going to write 3x squared plus. Now, I am going to use these two numbers here to rewrite the middle part of this trinomial. I'm going to write 2x plus 12x plus 8. Notice I split the 14x into 2 different terms, 2x and 12x. I have this part here. Now, the reason I have done this is I want to look at this group of terms and then this group of terms. The first group and the second group. And I'm going to factor only one of these groups at a time. I'm going to look at this group and see what factors it has in common. 3x squared plus 2x. 3 and 2 share no factors, but x squared and x share a factor of x. So for this group, I am going to factor out an x, which leaves me with 3x. I've taken one away, plus 2. 3x squared plus 2x becomes x times 3x plus 2. Now, I'm going to do the same thing for the second group. 12x and 8 share a factor of 4. 12 and 8 both divide by 4. It's the largest number that divides both of them. And they don't share any x's. So if I want to factor out the 4, that will leave me with 12 divided by 4 is 3x, and 8 divided by 4 is 2. So I factored each of these two groups. Notice what happened. I was left with the same portion for both sets of parentheses. These are common factors. So my answer, I can write 3x plus 2 out front by factoring out this common grouping. And then remaining was an x plus a 4. An x plus a 4. Notice I now have a factored answer. I used these groups to pull out front, and I'm remaining with the x plus 4, right? We're kind of combining the different techniques we have seen so far for factoring in order to deal with this 3 out front. So our final answer would be 3x plus 2 and x plus 4, which you can always check by refoiling, right? 3x and x make 3x squared, 3x and 4 make 12x, and 2x makes 14x, and then 2 and 4 make 8. So you can always double check your work with FOIL. Now, in the next example, we're going to do the same thing. We're going to use the first and last coefficients to multiply them. That's 10 times negative 1, which is equal to negative 10. So when I go to make my table, I want numbers that multiply to negative 10, right? I use this new value I calculated, right? Just like before. However, I want them to add to 3. So I want them to add to 3. So I need numbers that multiply to negative 10 and add to 3. Now, the 10 is negative, so when I write the possible ways to multiply to 10, I need to remember one of them will be negative and the other will be positive, right? One of these numbers, 1 or 10, will be negative, and same thing here. One of these numbers, either the 2 or the 5, will be negative, right? That's how we get a negative 10. However, if I want them to add to positive 3, I know the smaller number must be negative, right? I don't need to consider these cases where the larger number is the negative. The 3 is positive, so I know I'm confined to these top 2 cases, not these bottom 2, right? I want a positive 3. Negative 1 and positive 10 add to positive 9, whereas negative 2 and positive 5 add to positive 3, which is what we wanted, right? This is the row we want. Now, when I write these numbers, I can put them in either order. So I'm going to flip-flop them for this example. You don't need to, but I'm going to for a specific reason. I want to show something that's going to happen. So if I write 10n squared plus 5n minus 2n, right? I split the 3n into plus 5 and minus 2. It still is the same value, but I've split it. And then I have the minus 1 on the end. Now, I'm going to be looking at my groups here and here. Now be careful of the minus signs, right? You want to include this minus sign. Here it didn't matter, right, because the 12 was positive, but you want to make sure you're considering the minus. In my first group, 10n squared plus 5n. What do these share in common? Well, 10 and 5 both divide by 5, right? And n squared and n both share a factor of n. Now, in this group, what is remaining? 10 divided by 5 is 2, and n squared, factoring out of n, leaves an n. Now, 5n, factor out of 5n, that's the whole thing, right? Which, if you factor the whole thing out, leaves you with positive 1, right? 5n divided by 5n would be 1, right? Something divided by itself is always 1. Now, in the second group, right, we got the first group. In the second group, negative 2n and minus 1. That only shares a negative value as a common factor, right? If I factor out a negative 1, they would each become positive. And that's why I wrote it this way, to show that sometimes the factor might be only the number 1, or minus 1 in this case, right? Sometimes the common factor might not be all that inspiring. It might be a single digit, right? It might just be the number 1. Now, notice we got the same thing in both parentheses. That's key, right? We're trying to form the same group here. That's why we make these groups, right? Because these are the same factor, right? 2n plus 1 and 2n plus 1. That means I can factor that out, 2n plus 1, and let's see what's remaining. 5n minus 1. 5n minus 1. So my factored form becomes 2n plus 1 times 5n minus 1. Notice we've created groups, right? That's the key here, is you're looking to create convenient groups that allow you to then factor. Now, our next example, 20g squared minus g minus 1. Well, same as before, we need to multiply the first and last coefficients, right? The squared coefficient and the constant coefficient. That's 20 times negative 1, which gives us negative 20. And then we're ready to make our table of values. Now, we need to multiply to minus 20, and we need to add to, what number is in front of the g here? It's negative 1, right? It's negative 1 in front of the g, so they need to add to negative 1. Now, what are factors of 20? Well, 1 and 20, 2 and 10, or 4 and 5. Now, the 20 is negative, so one of the values has to be negative. Is it the bigger or the smaller? Well, if I want them to add to a negative number, the bigger number needs to be negative in each case, right? Just like before, we don't need to consider the case where the smaller number is negative this time. We only have to look at the bigger number. Now, 1 plus negative 20 is negative 19. 2 plus negative 10 is negative 8. And 4 plus negative 5 is the negative 1 we were indeed looking for. This row here tells us the values we must use. So, when we revisit the original equation, we want to split the middle part into 4 and 5. So it'll be 20g squared. Let's see, we can do plus 4g minus 5g minus 1, right? We split the minus g into plus 4 and minus 5. Notice it still gives the same thing. We're just trying to create those convenient groups. And then I like to put the little parentheses in to remind myself of the groups I'm looking at. That's just a temporary step, right, to help me keep the groups organized. In the first group, 20g squared plus 4g, well, 20 and 4 share a common factor of 4. 4 divides both 20 and 4. And then g squared and g share a common factor of g. So that is what this group has in common, is 4g. 20 divided by 4 will leave me with 5g, right? I'm taking one of the g squareds out. 4g divided by 4g, once again, that's plus 1, right? Now, minus 5g and minus 1, once again, those only share negative 1 as a factor, right? They both divide by negative 1. Negative 5 becomes positive 5g. Negative 1 becomes positive 1 after we factor out the negative, right? We take out the negative factor. So our common group was 5g plus 1. 5g plus 1. So just as before, we'll bring the 5g plus 1 out front, which will leave me with 4g minus 1. 4g minus 1. 4g minus 1. And there, we factored our groups just as we did in the other examples, right? 5g plus 1 and 4g minus 1. Now, our last example has a bit of an issue to begin with. This is not a standard trinomial. It's x to the 5th, x to the 4th, and x cubed. I need to factor out a GCF first. So I ask myself, what's the biggest term that divides 12x to the fifth, 10x to the fourth, and minus 12x to the third? Well, looking at the numbers, 12, 10, and 12, the largest number that divides all of those is 2. 12, 10, and 12 are all divisible by 2, and that's the biggest number that is true for. Now, x to the fifth, x to the fourth, and x to the third means they all share at least 3 powers of x, right? 5, 4, and 3. 3 is the smallest power that they would all share in common. So 2x cubed is a common factor of all of these terms. So my first step will be to factor out that 2x cubed. That will leave me with 12 divided by 2 is 6. X to the fifth, take out x to the third, would leave me with x squared. 10 divided by 2 in my next term would leave me with 5. X to the fourth, factoring out the x to the third, would leave me with x. And then the last one, minus 12x cubed, factor out 2x cubed, 12 and 2 make 6 when you divide them. X cubed, factor out x cubed, would leave no x's left over. So my new trinomial, after factoring out the GCF, becomes 6x squared plus 5x minus 6, which is of the form we were looking for, right? It's an x squared trinomial. That means we can use the techniques we used in these previous examples. Well, we're going to have to multiply the first and last coefficients of this trinomial, right? We've already dealt with the 2x cubed, so we're kind of going to ignore it for the time being. But we'll add it back in. We'll make sure we don't forget that it's there, right? 6 times negative 6 gives me negative 36. So when I make my table, I want numbers that multiply to negative 36 and add to positive 5, right? I need them to add to positive 5. So, how can I multiply to 36? Well, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't work, but 6 and 6 do, right? And those are all the possible factors of 36. Now, it was negative, so one of these numbers has to be negative, either the smaller or the larger. Now, I want positive 5, so I better make the smaller number negative, right? If I want a positive sum, so I'll make all of the smaller numbers negative. And then I will check what each row adds to. Negative 1 and positive 36 makes positive 35. Negative 2 and 18 makes 16. Negative 3 and 12 makes 9. Negative 4 and 9 makes, hey, 5. That's what we're looking for. And negative 6 and 6 makes 0. So the row I wanted was this one, the negative 4 and the 5. So these, negative 4 and 9, are the values I would like to use. So, the 2x cubed is still out front. I'm going to put a big bracket, and then I'm going to write 6x squared, and then I'm going to split my 5x into minus 4x plus 9x. I split the middle term, and then I leave the minus 6. And then I'm going to put another big bracket. And now my groups are this one and this one, right? Those are my two groups. 6x squared minus 4x is the first group. What do they share in common as a factor? Well, let's see. 6x squared minus 4x. 6 and 4 both divide by 2, right? 6 and 4 both divide by 2. And x squared and x share a common factor of x. So in my first group, 2x is the common factor. That leaves me with 6 divided by 2 is 3. Factor out one of the x's. Minus 4 divided by 2 is minus 2. And I factored out that x, right? I factored out that x. For my second group, 9x minus 6, well, there's no x's in common, but 9 and 6 both divide by positive 3, right? Notice the first number was positive this time, so we keep the positive, right? Here the first number was negative. Here the first number was negative in that second group, so we had to deal with the negative sign. Here it's nice because it's positive, right? 9 divided by 3 is 3x. Negative 6 divided by 3 is minus 2. And notice we got the same thing for each of our remaining groups. 3x minus 2, 3x minus 2. Be careful, though. Don't forget the 2x cubed out front. So I'm going to leave my big brackets, and I'm going to write 2x cubed out front. Now, I have one last step, and that's to work with this group here. I have 2x cubed. The group I factor out is 3x minus 2. And the group I have remaining is 2x plus 3. 2x plus 3, right? 2x plus 3. So my final answer, I have the GCF of 2x cubed. That's one of my factors. The next factor is 3x minus 2. And the last factor is 2x plus 3. Those are the factors for this problem. And this example combined GCF factoring with this new trinomial factoring where the first coefficient isn't the number 1, right? We had 6 here, right? It's not the number 1. So we have to do this new step of making these groups, right? We have to make those groups. And that is how you factor trinomials where the first coefficient is not the number 1. That leaves us with one final topic to talk about, and that's equations dealing with trinomials. Now, on this page, I have a bit of a blurb here that tells us how to solve trinomial equations. So let's read together. To solve a trinomial equation, first we must arrange the trinomial so that it is the form ax squared plus bx plus c equals 0. That is to say, we must set the equation equal to 0. We have to get 0 on one side of the equation. Everything has to be on the same side. Then, once we have the equation in the correct form, we then factor the trinomial. We factor what we have. After we have factored the trinomial, we set each of the factors equal to 0 and solve those equations. The answers to the factored equations are the solutions to the original trinomial. So it's all good to have the steps, but let's see how it works in practice. This equation right here, x squared plus 3x plus 2 equals 0, is already in the correct form, right? It's already equal to 0. So now I'm going to factor the trinomial, x squared plus 3x plus 2. This is a standard trinomial, right? There's no number in front of the x squared. So what I'm going to do is I'm looking for numbers that multiply to the number 2 and add to the number 3. Well, the only numbers that multiply to 2 are 1 and 2, and they add up to 3. So that's exactly what I'm looking for, right? So this trinomial factors to x plus 1 and x plus 2, right? X plus 1 and x plus 2. And that should be equal to 0 still, right? The equal 0 part didn't change. I just factored what was going on over here, right? I found its factors. Now, to get my answer, what I do is I make two equations. One for the first factor and one for the second factor. X plus 1 equals 0, and x plus 2 equals 0, right? One of these two values has to be equal to 0, right? I'm multiplying two things and getting 0, so either this is 0 or this is 0, right? One of the two has to be 0. And that will give me my two solutions to this trinomial. To solve this one, I subtract 1 from both sides, and I get x equals negative 1. To solve this one, I subtract 2 from both sides, and I get x equals negative 2. These are both my answer. Both negative 1 and negative 2 are my answer, which in set builder notation would be a curly brace negative 1 comma negative 2. There's two solutions, so I list them both in my group, right? This is one way to write the answer, or x equals negative 1 and x equals negative 2 is another way to write the answer, right? It depends on what format your answer is supposed to be in, right? As x equals the answer, or as sets, right? Where you put them in the curly braces. These are the two different ways we've seen us answer equation problems, right? So that's our first example. If you can factor and then set these equations equal to 0, you can solve trinomials. It's a two-part process, but we already know how to do both parts. We already know how to factor, and we already know how to solve these linear equations, right? So, let's look at the next one. X squared minus 5 equals 2x plus 10. I'm going to rewrite it because this is not in the correct form, is it? I'm supposed to be equal to 0. I'm supposed to be equal to 0. Well, I got to get everything off of this right-hand side. So I'll subtract 2x from both sides. Subtract 2x from both sides. There are no x terms on this side. There's an x squared term and a constant term. So these are three terms that are not like. So I will write x squared minus 2x minus 5. There's no way to combine those like terms, so I'll just write them in order that I want them, right? I like the x after the x squared, so I'll put it there in the middle. And notice I respected all of the signs. What's left on the right is 10. I almost have 0 here, right? I almost have 0 on the right. To get to 0, I got to subtract 10 from both sides, which now, there is a constant term, minus 5. So the minus 10 is like, which means we can combine these. Here they cancel, and I get left with x squared minus 2x minus 5 minus 10 is minus 15, which will now be equal to the appropriate 0. All I did was rearrange my equation to have it in the correct format. Now that I'm in the correct format, I can factor it. I can factor this trinomial. Well, I'm looking for numbers that multiply to negative 15, right? There's no number out front of the x squared, so I don't have to worry about that. And I want them to add to negative 2. Right? I want them to add to negative 2. Well, negative 15 can be found by 1 times 15 or 3 times 5, right? That's how I can get to 15. It's negative, so one of them has to be negative. In this case, it's the larger one because I want them to add to a negative number, right? I want them to add up to negative, so I'll make the larger one negative. 1 plus negative 15 is negative 14. And 3 plus negative 5 is the appropriate negative 2. So this row right here has the values I want for this equation. So now I can factor. So x squared minus 2x minus 15 will factor to x plus 3 and x minus 5. And that'll still be equal to 0. Now, I've factored, and I have it equal to 0, now I'm ready to set each part, x plus 3 equals 0, and x minus 5 equals 0. And then I can solve these little miniature equations. Minus 3 from both sides will give me x equals 0 minus 3 is minus 3. And minus 5, well, the opposite of that is plus 5. So I'll add 5 to both sides, will give me x equals positive 5. So my answers are negative 3 and 5, which if we wanted to use the other format would be negative 3 comma 5. Right? These are the two different ways we can write our answers, either as x equals or as sets with the curly braces. Now, the last example says 3x squared plus x equals 2. Well, that 2 can't be on the right-hand side. It's got to be the number 0 over there. So I'll subtract 2 from both sides. That'll leave me with 0 on the right, and 3x squared plus x minus 2 on the left, right? None of these are like terms, so I can't combine any of them. I still have 3 terms. Now, I want to factor what I have here. But I need to be careful. The first number in front of the x squared is not the number 1 this time, right? In these last two examples, it was the number 1, but now it's the number 3. So I need to multiply that 3 by the constant term, which is negative 2, which gives me negative 6. So when I make my table, I want numbers that multiply to minus 6, but add to, in this case, the middle term has a coefficient of 1. So they need to multiply to 6 and add to 1. Numbers that multiply to 6 are 1 and 6, or 2 and 3. One of them must be negative, though, because the 6 is negative, right? I got to make one of them negative. Let's see. To get a 1, I got to make the smaller number negative, right? I want a positive value, so I'll make the smaller one negative. Negative 1 plus 6 is 5, and negative 2 plus 3 is 1. So, this is the row that helps me out. Now, this doesn't factor it for me, though. Remember, I need to do the groups. I need to write 3x squared minus 2x plus 3x minus 2, right? I need to write the groups. 3x squared minus 2x plus 3x. I use these two to split the x, and minus 2. And that should equal 0. Now, first group, second group. In the first group, 3 and 2 share no divisors besides 1, but x squared and x, that shares an x. So I'll factor out an x in the first group. That'll leave 3x and minus 2, right? 3x and minus 2, you take out an x. Plus 3x and minus 2, these share no factors besides the number 1, right? The number 1 divides everything. So I'm going to write plus 1, and then in parentheses, I'll write 3x minus 2. It seems weird to write a 1 when it's not really doing anything, but you don't want to forget that they did share a factor of 1. You want to write it to make sure. And that is still all equal to 0. We're only manipulating the left-hand side. Now, our groups are the same, 3x minus 2. So I'll write that portion out front. And what's remaining is x plus 1. X plus 1. And that should all be equal to 0. So now, I have everything I need to create my solutions. I set each factor equal to 0. I have 3x minus 2 equals 0, which I can add 2 to both sides, which will give me 3x equals 2, which I could then divide by 3, which gives me x equals 2/3 as one of my solutions. And then the other one, x plus 1, let's write it over here. x plus 1 is equal to 0, I can subtract 1 from both sides. To solve that one is x equals negative 1. So my first factor gave me 2/3. My other factor gave me negative 1. So my answers are 2/3 and negative 1, which if we wanted to write in set builder notation, sorry, I kind of ran out of room here. I write a little big. We're going to get 2/3 and negative 1 as our set answer, right? We just write the numbers inside the curly braces. And those are 3 examples of solving trinomial equations, where we have a trinomial and we find their solutions, right? We find the values that would make them true. And that brings us to the end of our final notes packet. I wanted to take a moment to thank each of you for a lovely semester. I know remote learning may have its own unique challenges, but I hope that you found the course enjoyable and you've had a good time, and that as we enter these final few weeks, you are, studying for your finals, and I wish you the best of luck on any exams you may have. And I hope to see you all in live sessions as we wind down the end of the semester. And hopefully we have a strong finish and have a good start to our summer. Thank you all for joining me, and have a good one.